Hey class, greetings from Detroit. At a conference today, but I wanted to make sure that you guys got some information on our new topic. I can explain the difference between convection, conduction, and radiation. A couple things we need to know about heat transfer. It's the temperature is the average amount of energy of motion of each particle of a substance. Heat is transferred from a warmer object to a cooler object. Three different types that we've studied: radiation, conduction, and convection. So let's go ahead and start out with conduction. This is the direct transfer of heat when objects are touching. So the atoms or molecules are actually coming into contact with one another, and when a fast-moving molecule bumps into a slower-moving one, it actually transfers the energy. Closer the molecules are together, the more easily they transfer energy. So that's why the Earth heats up faster than the surrounding air in the atmosphere, because the Earth is a solid. In solids, the atoms and molecules are really close together, so it's very easy for them to transfer energy from one another. Convection, transfer of heat by the movement of fluids, and this can be either a liquid or a gas. Particles can easily move from place to place. What happens is when the atoms or molecules are close to the heat source, they gain energy and they start to bump into each other and spread apart. When they do that, they become less dense than the surrounding fluids and float up to the top. When they get away from the heat source, they actually lose energy. It cools down and becomes more dense and sinks back down to the bottom. And this happens as a cycle. And as the particles move, they actually take the energy with them from one place to the next. And I found an illustration here that kind of shows what it looks like. You can imagine this as either being a liquid or a gas. As you can see at the bottom, there's a heat source, and the heat source is actually adding energy to the molecules. As they become less dense, they rise up in the middle towards the top. When they get away from the heat source, they cool down, become more dense, and sink down to the bottom, and it just keeps continuing as a cycle. And I showed you guys the pepper in the water. As the water boils, the pepper, you can see it floating around. Same thing is happening in the room right now. The warmer air is rising up towards the ceiling. As it gets away from any heat sources, it cools down and sinks back down to the floor, and that cycle just keeps going continuously. This also happens in our oceans and in our atmosphere outside too. Third form is radiation. Radiation, don't think of it as like radioactive stuff. Radiation is a radiating heat. It does not require any contact between the heat source and the heated object to transfer the thermal energy, which is how the sun's energy can make it to Earth, because remember we said the sun is mostly empty space, very few molecules or atoms, so there's no way for it to transfer energy unless it uses radiation as a heat transfer. Direct transfer of energy by electromagnetic waves, and most of the waves that we get here on Earth that we feel are infrared radiation. Can't see infrared radiation, but you can feel it as heat. So for instance, if you've ever held your hand by the light bulb during the lab the other day, that was infrared radiation. If you've ever sat near a fire, unless your hand is directly above the fire where the convection currents are happening, you're still feeling the heat, but it's coming to you as infrared radiation. So just to sum it up, the energy can be transferred in radiation, conduction, or convection methods. These are all heat transfer. Radiation happens through electromagnetic waves. Conduction happens when materials actually touch each other. And convection happens in liquids and gases, and that's where you get the swirling motion. I hope this video has helped you. Please check back in on the video, review it as many times as you need it, and good luck on the quiz.